This is hydraulic lab, and you know what's gonna happen, right? They provide me a 2 masks since July 21st. They are now mandatory to wear the mask inside the campus. Okay, general safety rules: no food or drink in the lab. There's no more computer. If you've been in the lab or you've been on that NB building last summer, you've seen the changes, but there's no more computer in the lab. Everything is in the upstream. So you can use any software out there. And if you don't know, just let me know. And if you know, and if I'm not there or your instructor not there, it's not there, please share it. Okay. Or loud voices, including profanity words in the lab. Understand what you are doing in the lab before beginning the lab experiment. Now, pneumatics, PLC, electronics, they are not easy. They're okay because you're working on and low voltage 24 volts or 35 40 volts or 35 volts. Now in the lab on hydraulics it's easy, but you have to be very careful on the pressure. This is a high pressure. In your pneumatics, basically you have 120 psi. That's the pressure required by the manufacturing or by the government. And higher than that, usually you use a hydraulics. Now in pneumatics, you are only setting up 10, 15 psi, and your cylinder works. And what your main task there is the ladder logic, right? But now in hydraulics, our minimum pressure is 500 psi. So just imagine from 15 psi to 500 psi. So just imagine how is that how much force you can have on that 500 psi. That's why usually I said, oh, this is an easy subject. I can do it on whatever. So don't don't too much too much confident, because usually if you have a high pressure and if you have the leak and you don't know what's gonna happen on you or somebody else around you. So just be very careful. You will not you for sure. I'll gonna make myself available all the time there and watch you and make it sure that you're not gonna make mistake, right? Because everybody wants to go home. We already have this pandemic and you don't wanna hurt yourself. Next one, work with nobody and produce your own work. No hopping. Usually the students are like slacking. Okay, what's going on? What did I miss? Uh, what did I do wrong? Usually we are there. I'm not like, if you ask question, Arturo, I don't understand. Can you show it to me? Can you do it to me? What I want is you work on your own, and if you don't know what's going on, just come and ask me. Don't pretend that you know everything. That's very dangerous. That's why you are there. You are in Hamburg to learn, right? Because once you get your diploma and you start working, your buddy, your friend is no longer beside you. A lot of students, they're struggling PLC, my MBA, and any subject, but it doesn't mean they are the one that's not being hired. They stay in the lab, they practice. It doesn't matter your mark is 99% or 50%. Once you have a job interview, they're gonna ask you, do you know how to do this? If you practice a lot and if you know what you're doing, you're the possibility that gonna be hired. So it's not the mark that you can get. Obviously the mark, but be very careful, or once you get out in the room or once you get out in Humber, what did I learn to, can I work by myself? That's what I'm trying to do, or to, if I said produce your own work. I'm not there to give you hard time. Anybody who's under me, I'm willing to share a little knowledge that I have, as long as you learn something. Because if you're only watching, it's hard to learn. But if you're doing it, you will know. Okay, only perform experiments especially assigned by instructor. I don't know your situation. Some of you guys are sick, some are working. If you don't have time, let me know. I can adjust my schedule, or I can let you in if there's available uh, beds on the other in the lab. I can let you in. Just be true to me. Like, oh Arturo, I don't have time. I'm working. Oh Arturo, not that. Oh, I got so much last night. I don't want to go to school. Just be prompt to me, and I'll try my best to help you. Okay, tie back your hair, roll up sleeve, put on or leave on any required safety protective equipment in the lab. This lab, or this course, mainly will be working on oil. So maybe you want to use. We don't provide gloves, but if you want your coverall, you can borrow it from the mechanical tool room. I think you can give it to them your ID, and they can lend you the coverall. Good. What's next? This one. This is the bench that you'll be working on, and I'll show you how it's being operated from top to bottom. This is just scaled down to 10%. Whatever machines you have in there with hydraulics, this is the setup. You have a hydraulic motor, you have the solenoid valve, run or operated by solenoid A and B. You have your manual solenoid valve. These are the port. Mm, okay, there's a start. I'll show you that to you in the lab. This is basically a video, but I'm gonna run through first what's my requirement. The next one is safety precautions. Guys, you are required to have a safety shoes and safety goggles and mask. Okay, so if you get in there, I'm pretty sure you already have this safety shoes in hand with you. And I don't know if it's in your locker, but I believe. Are you allowed to use a locker, guys? No. Hello? Hello? Might need to pay. Why? But at least you have your goggles and mask, okay? A lot of a lot of newly graduate who is working in the industry, they'll never have an major injury. All the major injury that I've seen myself, personal experience, was those veterans. They've been working for the last 20 years, 30 years. They're too confident in themselves that can be safe. But please protect yourself. Okay. Uh, on this one is we're in pneumatics. We're working what air, right? You just have a compressor and fill it up with air, and then you can just discharge. Over here, there is I think 9 benches that work separately to each other. So these are hydraulics benches and run with oil. So first of all, if you are running or you're trying to make the lab or experiment, make it sure that you have this oil. It's like your car. If you're driving your car, make it sure that there's a gas, right? And there's an oil there too for your coolant and coolant for your engine. So just check it out before you turn it on, because once you turn it on and try to switch solenoid A and B and no oil's coming in, what's gonna happen? Those motor is not interlocked with your uh, oil level or the quantity of oil in the reservoir, so it will not automatically stop. This one is, but in your case, once you're working outside, everything is category 4 and it's all what? Interconnected, interlocked. So if my oil is low, and then you have your pressure switch or your float switch, that will the machine will not run. Same as when you have overflow, then it will shut up your machine. That's your job outside. That's easy programming. But in this case here, please take a look on the oil level and do not operate below mid class. I'll show it to you in the class. Okay, these are high pressure machines, and hoses are to be connected correctly, A and B. Inspect hoses and components for sign of damage, lost connections, missing part, and oil leak. A lot of students like said, oh, it's easy, A and B. Yes, it's easy, but these are hydraulic for educational purposes only. A and B, you made a mistake, you put you connect hoses for B instead of A. It's easy on Humber. However, when you start working, say you start working in GM, Ford, Chrysler, Honda, Toyota, whatever, and you have 3,000 cylinders out there. You have the binder which one, but what happens if you connect A to B or B to A? What's gonna be the repercussions of that machines? What is the movement, right? So be very careful. In this case here, in lab at Humber, there's only 2 cylinder in hydraulics. So try to familiarize, familiarize yourself or make a habit that A is connected to A, B is connected to B. What is this? If you don't know, behind the cylinder is the A port. On the right side of the cylinder is the B port. Just remember that. Or just remember one. What is A behind the cylinder or in the piston side? What is B? Or it's in the rod side. Just remember one, because if you remember both, then you're gonna have maybe if you forgot something, just remember the easiest one is B is in the right side, on the rod side, and that's it. Okay. Obviously, this is a 3,000 maximum pressure limit on the hose. We are using only 500, and the press the motor the motor can only give such revolutions to produce 1000 psi. Other than that, it will shut off the breaker. That's the only way we have that interlock or safety. So check it out. And obviously, before the summertime, before fall, or before the any semesters commence, we check everything. But we always, everybody is not perfect, right? They might forget or overlook something. Okay, this one, everybody still with me? Somebody send a message. Who's this? Okay, everybody still with me, right? Okay, in the lab, this one, it says do not connect T or cross coupling to the pressure gauge. These are the coupling. These are the coupling that you can see in here. There's a cross and there's T. Do not, please, do not put cross or T connections on the pressure gauge. I'm not saying it's wrong. In the industry, you have pipe, you can put anything you want. But in here, this pressure gauge is only tack weld three-tack weld. So what happens if you have high pressure and if you don't release it, you cannot remove your hoses. Then you try to force that, and everybody is a strong guy. So please don't do it because it's gonna break the weld at the back. For me, I will not give you a minus mark on your lab report, but some teachers will do because they're gonna reiterate most of the time that please don't use coupling in the pressure gauge connection. Okay, next, avoid excessive pressure or resistance to flow. Obviously, there is a pressure gauge, relief valve pressure, PRB. So we are not probably having this problem, but to make it sure, if you have only 500 psi requirement, don't put in your 600, or sure the relief valve will open at 480 psi. If you set at 500 psi, at least 10% will open up the pressure relief valve. What happens if the pressure relief valve doesn't work? So which one's gonna break easily? The weakest point, right? The weakest point will be your strongest point in the system. You know what I mean? Because that's the one to break right away. So you cannot pass that. So your weakest link is the strongest point on your system. So if you think you have that weakest point, and you know how much pressure or force can get in, you go below that because that's the biggest, or this the maximum strength that you have on the system, weakest link. Okay, next is, okay, your hoses is the same as in your pneumatics. There's a clip in the coupling inside. This one here, there's a spring loaded in the hose. So what they call, there's a male and female plug it in. So this one here, right underneath the word hoses are connected and locked, there's notches and pin. If you plug that hoses in and this is aligned, it's connected but it's not locked. So in order to lock, either you turn clockwise or counterclockwise. Okay, so in the same token, if you want to remove it, make it sure that the pin and the nuts will be aligned, and just gonna slide this cover plate from the hose. Okay, next is relief drop pressure. Usually once you finish out, you shut it off through this stop and start button. That's not the proper way. What's gonna happen is you will de-energize the solenoid of this directional control valve, and all the fluid in your system circuit is trapped, and it will not go back to the reservoir. So what does it mean? The next guy, you can remove all the hoses for sure, but the next guy will be having a hard time to put it in. That's why they have this ratchet tool. It's gonna be in the end of the slide. So make it sure you relieve it to zero. I will show you how to do it on the lab. Okay, next. Once you're usually in pneumatics or in NB 109, a lot of students that they're rushing, and then they just leave everything, uh, those wires. In here, please clean your hydraulic vents at the ends of the lab period, and make it sure there's no oil that's slippery. And the main thing is do not energize until the circuit has been checked by instructor. So basically what you're gonna do in the lab is it's everything pre-written for you. It's prepared. You just redraw the circuit in the automation studio and run it yourself. And then once your instructor says, okay, your automation studio works, now print it out and build your circuit. However, once you build your circuit, please do not turn the machine on. Ask my approval before you turn it on. Okay? This is the one. Once you don't this tool here, it's a ratchet. With the head, either you can make it turn clockwise or counterclockwise. It depends on the settings you have here. So if you don't release your oil in your systems properly, you will need this. At this moment, 80% you need this because this one are old machines, 1996. Probably you were not born then. So this one, this ratchet will be used by you no matter what at one point, and any of those connections will be loosened up by you. If not, I'll show you. Okay? Okay, avoid hydraulic spill, air you can just discharge to the air, but or to your environment, but the oil it's not. You have to return to the reservoir. And obviously immediately report incidents. A lot of when these are the torque is very high. Say for example, Alex is a strong guy. He tightened up that plug once he released the oil. Just be very careful, and if you have that, let me know. I have Band-Aid all the time. And obviously, with the pandemic, wash your hand before leaving the lab. There is a sink inside the lab. Your lab 1 is about cavitation, and this is your lab 1, industrial or standard hydraulic circuit. In this lab, you have all the procedures. You still can see it. In this first lab, you will assemble and set the system pressure of a basic hydraulic circuit. So you have all the procedures in here. Basically, what you have to do is just reading the pressure and the flow. So basically, you have to redraw this drawing, and then once you redraw it, show it to me, and then I will check if it's okay, and then you guys can build that drawing. What is the functions of the relief valve? Is the relief valve considered to be normally non-passing and passing? Why should the hydraulic systems have started at low pressures? Define cavitations. Usually, what is the functions of the relief valve? By the word itself. If you have a high pressure, you have to relieve that whatever in excess of that setup pressure. It's what is the relief valve considered as? It's always closed. It don't open when that excess pressure comes in. So if your 500 psi pressure is set, that relief valve is still closed. It will only open once you have that higher pressure. So this is normally non-passing. Why should the hydraulic systems start at low working pressure? Usually you know what's going on. There's in relative to electricity, you have the surge current, right? So you start with low pressures. Take a look. Once you turn it on and set up whatever pressure you have, take a look at your systems. Is there any leak? Is there something wrong? Right? So cavitations, aerations, on the cavitations and aerations. Do you see that slide? That slide is about cavitations and aeration. So basically, what happened in the pump inlet is you don't have or before you start the machines, you don't have anything, there's no oil in there. So you have to create a vacuum which is lower than 14.7 psi in order to pull it out that oil from the reservoir. So that's basically principle of starting the hydraulic equipment or hydraulic systems. You have to create a vacuum when you start the motor. The motor is cooled with pump, and the pump will turn depends on the motor turns. But in that pump blade to the reservoir, you have to create a vacuum in between in order to suck the fluid in. However, if there's not enough oil that's delivered to the pump, that will create a cavitation, meaning you're starving the pump. So basically that's the cavitations. And the same token, the aerations. The aeration is, say, a lot of maintenance people replace the component, and or if the systems is running and there's a leak, what's gonna happen? Your system pressure is 500 psi in your hydraulic system, and if it's running through and if there's a leak, the pressures on the atmosphere or your surrounding is 14.7, and your pressure inside your system is 500 psi. What's gonna happen? It's gonna bring in the less pressure. So you have the oil, and if there's a leak with low pressures on the air outside, will bring into your systems. That's basically the aeration. And what are the causes of the cavitation? Collapsed hoses, clogged suction, cold fluid. That's a very common. This hydraulics is just an introductory. But if you're working on a servo valve with hydraulic system, you have to make it sure that it's not cold. The viscosity must be what? In operating conditions provided by the manufacturer. Cavitation technique to troubleshoot and correct the system. Install vacuum gauges. We have vacuum gauges there. I show it to you. Repair to the manufacturers of the pump, normal conditions as well as the temperature and suction filter. Aside from suction filter, aside from operating temperature, you have to have heat exchanger. This one, like I said, what you have in the class or in this class is just introductory. Once you're working on the big project, say for example, this one, the hydraulic systems that we have is only 10 gallon. If you start working on 100-gallon reservoir, then you have to have a heat exchanger. Okay, that's aerations. You have it here. It's introductions of air bubbles in the pump inlet or in the system. Pump inlet resistance, pressure drop. Obviously, if you have a pressure drop, what do you need? What do you need if you have low voltage or low current? You need a capacitor, right? So in this case, you need an accumulator if you have a pressure drop. Shock waves due to sudden closing of the valve and low oil. Okay, everybody knows how to use the automation studio, right? Where is it? It's already in the upstream, right? So your upstream is there. What it's look like, people doesn't know, the upstream is like this. This one here, this is your upstream. If you go to that upstream and apply technology, don't click your standard. Click your graphic design. That is where that automation is being kept. Okay, and then you redraw the circuit number one, redraw that, and save it. Make it sure you save it, because once you use the software in the upstream, and if you don't save it, as soon as I think 5 minutes you close that program or software, it's gonna be clean up your work. So make a habit to save it all the time. I remember when I was a corporate planning engineer, I worked on a drawing for 4 hours and I forgot to save. Guess what? I have to redraw it all over again. Okay, so just make a habit of anything that you save it. Okay, your marking scheme. Your marking scheme is like this. Okay, I'll show it to you, your marking scheme. Stop sharing, Windows application, and share. This